Evening. So I am Dr. S. Arun from Sri Sanmuha College of Engineering and Technology, Sangagiri, Salem. So Department of Science and Humanities. So today I am going to discuss about magnetic properties of materials. So magnetism. So basically magnetism or magnet having two poles. So one for north pole and another one for south poles. So same poles repulsion and then opposite poles attraction. Already you know the basic of magnetization or magnetic field or magnet. So now, so magnetization is a phenomena by which a material exerts either attractive or repulsive force on another. So basic source of magnetic force is movement of electrically charged particles, and then this magnetic behavior of a material can be traced to the structure of atoms. So electrons in atoms have a planetary motion in that they go around the nucleus. This orbital motion and its own spin causes separate magnetic moments which contribute to the magnetic behavior of materials. So thus every material can respond to a magnetic field. So however, the manner in which a material responds depends much on its atomic structure and determines whether a material will be strongly or weakly magnetic. So here the strongly and weakly magnetic, it is depends upon the magnetic field except the materials. So why not all materials are magnets? Some example for some material act as a magnet, some material do not act as a magnet. So because of what is the reason of some material act as a magnet, some material do not act as a magnet means it is the properties of materials. For example, iron particles is accept the magnetic field, then only this material act as a magnet sometimes. For example, if consider plastic materials do not accept the magnetic field, that's why these types of materials are not magnetic field or magnetic materials. So, as every material consists spinning electrons, each of them could be a magnet. So, fortunately, not so. There are two reasons for it. The first, according to Pauli exclusion rule, two electrons with the same energy level must have opposite spins. Thus, so are the magnetic moments which cancel out each other. Second one, so orbital moments of electrons are also cancel out each other. There's no net magnetic moments if there is no unpaired electrons. Some electrons such as transition elements, lanthanides and ancinides have a net magnetic moment of their energy levels have an unpaired electrons. These are the reason for some are magnet or they act as a magnet. Then magnetic dipoles. Already you know magnetic dipoles. Dipoles means whole di means two. So dipole means magnets having so two dipoles. That means one for north pole and another one for south poles. Magnetic dipoles are found to exist in magnetic materials analogs to electric dipoles. A magnetic dipole is a smaller magnet composed of north and south poles instead of positive or negative charges. Within a magnetic field, the force of field extract a torque that aims to orient the helps the dipoles with the field. Therefore, magnetic forces are generated by moving electrically generated particles. Again, I repeat, magnetic forces are generated by moving electrically charged particles. These forces are in addition to any electrostatic forces that may already exist. It is convenient to think magnetic forces in terms of disturbed field, which is represented by imagination. Therefore, above these lines are also indicated the direction of forces. Types of magnetism. There are the three different types of magnetic materials is available. So one for diamagnetism, and another one for paramagnetism, and third one for ferromagnetism. So antiferromagnetism and antiferromagnetism and ferrimagnetism are considered as subclasses of ferromagnetism. Diamagnetism. So weak, very weak. So very weak exists only in the presence of an external field. That is, these types of materials are called non-permanent magnetic materials. Applied external field on atoms of a material, slightly unbalancing their orbiting electrons and creates a small magnetic dipoles within atoms which oppose the applied field. This action produces a negative magnetic known as diamagnetism. The induced magnetic moment is small and magnetization direction is opposite to the direction of applied field. Upon thus, the relative permittivity is less than unity. Magnetic susceptibility is negative and is in order 10 to 5. So materials such as copper, aluminum, zinc like examples for of the diamagnetic material. Then next one, paramagnetism or paramagnetic materials. So slightly stronger. So when an external field is applied, dipoles line up with the field resulting in a positive magnetization. However, the dipoles do not interact. Materials which exhibits a small positive magnetic susceptibility in the presence of magnetic field are called paramagnetic and the effect is termed as paramagnetism. So, in the absence of an external field, the orientation of atomic magnetic moments are random, leading to no net magnetization. So, however, because the dipoles do not interact, extremely large magnetic field are required to align of all the dipoles. In addition, the effect is lost as soon as the magnetic field is removed. Paramagnetism is produced in many materials like aluminum, calcium, titanium alloys, and copper. Antiferromagnetism. So dipoles line up build but in opposite direction, resulting is zero magnetization. Magnesium, chromium, MnO, NiCO, MnCl2 is the example for a antiferromagnetism. Exchange interaction, which is responsible for parallel alignment of spins, is extremely sensitive to interact atomic spacing, do not the atomic positions. This sensitivity causes anti-parallel alignment of spins. When the strength of anti-parallel spin magnetic moments is equal, no net spin moment exists and resulting susceptibility are quite and small. One noticeable characteristic of antiferromagnet is their attained maximum susceptibility at a critical temperature called Neal temperature. At temperature above this, antiferromagnets become paramagnetic. Ferrimagnetism. Some ceramic materials exhibit the net magnetization that is called ferromagnetism. So these are all the examples for all this ferromagnetic material or ferromagnetism. In a magnetic field, the dipoles of a caution may line up with the field, so while dipoles of other caution may not. These ceramics are called ferrates and the effect is known as ferrimagnetism. Below the Neal temperature, therefore, ferromagnetic materials behave very much like ferromagnetic materials or paramagnetic above Neal temperature. But therefore, this ferromagnetic material is depends upon the temperature. These materials exhibits a large but field-dependent magnetic susceptibility similar to ferromagnets. They are also show Curie-wise behavior, as these ceramics are good insulators, electrical losses, and minimum, and hence the ferrates have a lot of applications in devices such as high-frequency transformers. Thank you for listening my words, and my heartful thanks to our Sri Sanmuga College of Engineering and Technology. This for wonderful opportunities for this video making. Once again, thank you.